Hi everyone. In the previous classes, we have seen various kind of flip-flops. So like SR flop, JK flop, D flip-flop, T flip-flop, and also we have seen the conversion of one kind of flip-flop to another kind of flip-flop. Right? That flip-flop can be any kind of a new flip-flop also. It is not only meant for like JK, SR, T or D flip-flops. It can be any kind of flip-flop. Right? Yes. Basically, these flip-flops are classified into two types. One is synchronous flip-flops, which you know already these terminologies, and another one is asynchronous flip-flops. Right? So far, whatever flip-flop that we have seen, all will be comes under synchronous flip-flops because the outputs are going to produced depends on the clock signal. Depends on the clock signal, they are going to work. Meaning that whatever the input that you are trying to pass for SR or for JK or for D or for T flip-flops, they are going to be simply controlled through a simple clock signal. Meaning that synchronously controlling all kind of inputs. So we are going to call it as synchronous flip-flops. Right? So if this clock is going to be off, entire your circuit is going to be in off state. Right? Yes. But when the clock is passes, the way you are passing the clock, meaning that clock value can be a high voltage or it can be a low voltage. Right? High voltage, I am saying it in terms of active low. Right? You know, right? The levels of the levels are various kind of things, right? Active low and active high. When it is 0, it is high. When it is 1, it is low. Actually, right? In active low situation, I am trying to define. Whereas coming to active high situation, active high situation, 0 means normal one, 1 means high value. I hope you remembered all these things which we discussed in the earlier classes, right? So meaning that in synchronous flip-flops, your circuit is going to work based on the condition of the clock, signal. Coming to asynchronous flip-flops, the output of the flip-flop, may changes regardless of condition of clock signal. That is what asynchronous flip-flops. I mean, in the earlier class itself, I have taken the definition. If you are going to have the inputs, these inputs are not going to be controlled by any kind of a clock signal, then I can call them as asynchronous flip-flops. Or in other terminology, if I say, if these inputs are going to be controlled by clock signal, even if you are going to use some kind of extra things like we can call as preset, and another one is we can call it as clear. With help of this also, we can able to make our flip-flop into a kind of asynchronous flip-flop. How, sir? Right? So let me tell that. Right? So basically preset means what? I am going to set it to the value 1. Clear means I am going to set it to the value 0. That's it, right? Irrespective of the clock signal, whether you are passing the high clock or whether you are passing the low clock, it doesn't bother. Always these two are going to have highest priority. So first highest priority will be given to clear, second highest priority will be given to preset, right? So the thing is here, again, as per earlier discussions, 0 means clear only, but the point is this 0 and 1 are a kind of things which depends on again active low and active high. Guys, basically if you try to say the general meanings of preset means setting the value to earlier value, right? Earlier value means something like setting the value to 1. Clear means it is going to produce the really like entire value is going to replace with the value 0. This is the general meaning, right? If you look into how we can generally represent with respect to various kind of flip-flop. For example, if I take JK flip-flop, right, I am going to define only schematic diagram. If I take J and K are the two inputs, basically we are going to pass a kind of a clock signal, right? This is a kind of a JK flip-flop and it is going to produce the outputs Qn bar. Similarly, if I take this one, this is another kind of a thing, JK. So this is a kind of thing, right? So the difference between these two is this is a kind of positive edge triggered. This is a kind of positive level triggered, right? So depending upon the way that you are passing the clock, your circuit is going to be behave, right? So similarly, negative edge triggered, negative level triggered, right? I hope you remembered everything, right? And also, if you are going to say anything, we can define the logic levels also, right? One is active low, another one is active high. Means I said earlier, right? Active low means 0 is high value, 1 is low value. Active high means 0 is low value, 1 is high value. So depending upon the way your representations, they are going to completely vary. Okay, fine. Now, how can we convert these flip-flops into a kind of asynchronous flip-flop, right? So up to now, these all the things we call it as synchronous flip-flops only. If I would like to convert them into asynchronous flip-flops, we are going to connect a preset, PST, and another side is we are going to use clear, or we can call it as clear. So this first one, I can call it as a kind of asynchronous JK flip-flop, and if I connect like this, PST, and this is a kind of a clear, CLR, I can call this, the B is also kind of asynchronous JK flip-flop, but asynchronous JK flip-flop of positive level trigger. Second one, like A is asynchronous positive edge JK flip-flop. So depending upon the representation, you can able to call in variety of ways. Okay, fine. And now how they are going to behave? See, like exactly how they are going to behave for the JK flip-flop, right? So basically, if I try to take the function table of JK flip-flop, JK, and how the Q1 plus 1 is going to behave, 0 0 0 1 1 0 1 1. For 1 1 it is going to be toggle, for 1 0 it is going to be set mode, for 0 reset mode, for 0 0 it will be a kind of latch state. This is the function table of JK flip-flop. But the thing is, these are not going to work at certain situation. What at certain situation? When you are going to use preset activated or clear activated. I mean, if I try to say, let me tell clearly, in active low situation, see, you are going to have various variations. In active low situations, how the preset situation and how the clock is going to be work, right? So if I say, if I am going to have positive two values right here, so 0 0 0 1 1 0 1 1 1 0 1 1, and how your Q might be affected. See, the point is, as these asynchronous flip-flops, they are going to produce the output independently, irrespective of the clock signal. That is what I am trying to say. So that's the reason we are not going to look into the clock signal, how it will be, right? When you are going to have 0 0 0 0, that we'll see what will happen at the later point of time. But when you are going to have 0 1, your output is going to be 1, meaning that irrespective of J input, K input, or clock signal, it is always going to produce the 1 out the Q1 level. Whatever the Q1 bar, that will be 0. Similarly, when you are going to pass the PST as 1 and clock as 0, Q1 will be 0, meaning that it will be in the reset state. So clear will be clear state, right? What about 1 1? In 1 1 situation, it is going to works normally, right? Coming to 0 0, coming to 0 0, we are saying that when we are going to have 0 1, when clock is 1 0, when clock is 0, definitely you have to reset it, you have to clear the data, right? Here what they are trying to say in the first thing, preset is 0 and clock is 0, meaning that they are trying to combine these two, but combining these two may lead to ambiguity, right? So we can say that these should not happen, that's it, right? So the point is, when preset or clock levels are changes, your output will be changes. But the point is, specifically, if you would like to work your JK flop as usual normally, then you have to pass the PST and clock as 1 in place of active low. Similarly, you know, right? So you can have the alternative for this. When you are going to have active high, how you have to represent. So PST and clock 0 0 0 1 1 0 1 1, and it will be QN. When, so it is just exactly opposite to the active low state, right? So when it is 0 1, when it is 0 1, so here it will be 0, because it will be act as 1 0 now, 1 0. For 1 0 it will be 1, good. For 0 0 it will be normal state. See, no need to explain this thing again and again, right? You know the meanings of it. When it is 1 1, this should not happen, right? So if you remember this one, we can able to simply define how the JK flop is going to work, right? Similarly, for SR flop or whatever flops you can able to write, all those we can able to write by simply passing preset and clear comments, right? For example, if I try to draw one kind of signal, if I say a kind of signal will be like this. Yes guys, listen here. I have taken one clock signal. See, I am trying to represent the timing diagram for JK flip-flop, that too for negative edge triggered, right? Meaning that when your clock is at the negative edge, we are trying to represent how this JK flip-flop is going to work for the asynchronous inputs and with respect to JK inputs, right? So I am going to call it as JK flip-flop negative edge triggered. So if I try to say how this particular JK flip-flop is going to work for the asynchronous inputs. Okay guys, you know already when you are going to have J and K are the inputs, and what might be the next state, how we are going to get, right? So this is what function table I am trying to draw here. 0 0 Qn, for 0 1 it will be reset state, for 1 0 it will be set state, for 1 1 it will be toggle state, right? This is, you know. Now let us try to check how this particular timing diagram works, right? So basically your clock is at the red color, and pre or the clear are the two commands which are kind of asynchronous inputs, means they are going to have the highest priority, right? First highest priority will be given to clear, second highest priority will be given to pre, and third highest priority will be given to JK flip-flop, right? This is what I am trying to say with respect to the given thing also, right? Those rules, right? Now this timing diagram I am trying to think about with respect to active low. Okay, fine. And when this particular thing is going to change its output, whenever it is going to be a kind of negative edge triggered, guys. You have to make sure to understand this one. Okay, fine. So if I start at a particular point, something like this, assume that this is a kind of high end. Okay, fine. Now first what it is going to check, it is going to check for the clear command, right? Clear command is 1, pre command is 0, clear command is 1, clear command is 0, right? When clear, it is opposite dimension, so PST is, so this should be preset. I can write in any manner. Preset is 0 and clear is 1. So the state will be 1, meaning that it won't consider about the inputs, it will just produce the output as given, right? So meaning that it is going to produce high. High up to which location? Up to this particular point of time. Up to this particular point of time it is going to be high. But if you look into this point, is it a kind of negative edge? No. So it will still continue. So whenever it observes negative edge, then only it will start changing its output, try to change its output, right? Now if you try to extend the diagram up to here, yes, now negative edge observed. When negative edge observed, what might be the preset and clear commands? Preset and clear are 1 1. When preset and clear are 1 1, it is going to work normally. Normally means what? However JK Flip-Flop is going to work, the same thing it is going to work, right? Now it is 1 1. It is 1 1. When it is 1 1, when it is 1 1, it is going to work normally. That's okay. So normally means what? You have to check about the JK Flip-Flop, right? What might be its positions in the JK inputs? This will be 1 and this will be 0. When 1 0, it is going to be set. It's going to be set. So it will try to continue all the things until next edge will comes, right? So next negative edge will come, right? Next, once negative edge will come, this is again 1 1. 1 1 is works normally. So you have to go for checking the JK Flip-Flop. So JK Flip-Flop, it is 1 1. When it is 1 1, it is going to toggle its state, right? So toggle done, and it is going to do until the next negative edge. Yes, here it is 1 1. When it is 1 1, you have to work like normal, and here also 1 1. So it will again toggle until this particular point of time or the next clock signal, right? So when it comes to, when it reaches to this particular point of time, here you got the priority will be given to clear, right? So it is set to 0. So that's why it will be 0. See, preset and clear are not going to check about the clock signal. They are going to work according to the values what they are having. So it won't look into the clock signal. When it is clear, asking for clear, it will simply clear, right? So this will be done up to this point of time. Wherever it is clear, it will be given, right? Yes. Once it reaches to this point, now this will be 1 1. It works normally, right? Normally, and we have to go for changing its output, right? When it is going to change its output until next clock signal, but it is not in the next clock signal, so it will continue up to here. Now it is 1 1. It is 1 1. So it will change its state. Okay, fine, and then it will continues until the next thing. So again it will continue like this. So because it is a kind of JK Flip-Flop, right? So this is the timing diagram for JK Flip-Flop of negative edge triggered, right? So now let us try to do one more kind of example which will clearly explain for you how to define JK Flip-Flop positive edge triggered, right? So JK Flip-Flop positive edge triggered, the two which are in asynchronous. Guys, in synchronous we have seen already all those, right? Yes. So if I try to take the clock signal, yes guys, so this is what clock they have given. So we are trying to say that this is the timing diagram for JK Flip-Flop positive edge triggered. So wherever positive edge is there, your output may change, so you have to take care of this. So that's why I am making some arrow mark here. And that too, it is asynchronous. Asynchronous means what? So we are going to have preset command and you are going to have clear command. So for those inputs also it is going to be affected. See, if I try to say it is a kind of active low. So when the preset and clear 0 1, your output will be 1, 1 0, your output will be 0, and for 1 1 they are going to works normally. For 0 0, we cannot able to say that this should be happen, right? It should not happen, right? So you know this one. So now if I try to say, I am at this point of time, as it is not a like kind of a clock, so we should not think about the clock here. Preset is 0, clear is 1, so you have to get this case. So irrespective of the j and k, it is going to be high up to this point of time, right? And if you are able to observe, this is a continuously a kind of a preset is 0, right? So at this point of time you have to make sure to continue this one. So when you have to check for inputs only, whenever preset and clear are 1 then only you have to bother about all the things. So I have to make sure to write up to this point of time. And also if you are able to observe here, it is 1 and it is 0. So at this point of time you should not think about anything, you have to take care of writing the direct the 0. Writing the 0, right? Because when it is 1 0 you have to write as 1 0. So and in the remaining cases of the timing diagram you have to check for the JK, right? So if you are able to observe, as up to here you have written, now you have to this one continue until next edge, next positive edge, right? So that's why I have continued up to here. When you reach to this point, this is 1 and this will be 0. For 1 0 it will be in the set state. So I will continue. Once I will start continue, it will try to continue until further positive edge. Yes, I am at the positive edge. Now it is 0, this will be 0. When it is 0 0, it should be in the same state. It should be in the same state, right? When it is in the same state, yes, when it is 0 0, you have to continue further until the next stage, right? Now it is 1 1. It is 1 1. When it is 1 1, you have to make sure to toggle. And if you go for further, again you are going to make it toggle. Again you are going to make it toggle further, right? So if you are able to observe, again toggle. But when it comes to here, this point of time, yes, it is going to look like this. And here it will be 0. That is fine, right? Now once it completes this one, again it is going to have 1 1. When it is going to have 1 1, again it is going to check for JK. But is the clock started? No. So it will continue still further. Once its clock started, again it will move like this. So this is the corresponding output for the JK flip-flop positive edge triggered. Right, guys, don't worry about the way it look like the diagram, but anyway the down level defines 0, this is 0, this is 0, like that you have to take care of this one. Okay, I hope you understood clearly how the JK flip-flop is going to work for asynchronous inputs of various kind of edge triggers. Thank you.